Hi there again, Gordon West, WB6NOA. Congratulations. This is the final review in preparation for your 801 total questions reviewed, test of which 50 will be on your Element 4 extra class examination. All exams administered after July 1, 2002, all the way through June 30, 2006. The extra class test will use the exact questions and answers found in my exclusive Gordon West extra class book, as well as on this audio course. There will be no change of the A, B, C, D answers, nor the questions. No numerical value changes permitted at all. The only thing that could change is the order of the A, B, C, D answers. But the exact wording and numerical values for right and wrong answers will be identical to what's in the book. We're going to first review some important points to remember for taking the extra class test. And prior to taking the test, you need to check in to an examination site. And to find out where that examination site is and when they will test, call 800-669-9594. That is the W5YI Volunteer Examiner Coordinator System. They have examinations as well as the American Radio Relay League all over the world and certainly everywhere here in the United States. So call that 1-800-669-9594 as the first number to find out when and where an examination will be offered near you. Next, contact the examiner in charge of the session and let them know when you will be taking the test. They will remind you of the test fee, approximately $10 or a little higher. They'll remind you to be sure and bring identification, pens and pencils. They'll permit you to bring your non-programmed calculator. Now, you can bring a programmable calculator, but don't have anything programmed in it. Be sure and bring a copy of your present license, plus the original, if you have it, of your current license. If you don't, call that 800 number and they can explain where to log on to be able to electronically download your official FCC amateur radio license. To take the extra class test, you must presently hold a certificate for general class or advanced class, which is a grandfathered license. You will need to have one or the other in order to take the extra. Now, if you've not taken the general class, you could do that at the same session, but that's another set of my audio cassette course, and it's another book that I have for general class. But if you have the general, which I'm sure most of you have, and some of you with the advanced class ticket, then be sure and bring a copy plus the original of your license, and you'll be all set. Any questions about what to bring to the examination, ask the 1-800-669-9594 personnel or check with a volunteer examiner who is the contact person in charge of the exam session. When you get to the exam session, if it's in the morning, I recommend bring donuts. Tell them that you and Gordo want everyone to have a great time at the session. They'll appreciate that. And dress appropriately and be prepared to be well greeted by all of the examiners that are offering their time and service free of charge. And tell them all how much you appreciate taking the exam with them. After you pass the test, we too hope that you'll become a volunteer examiner, and you can call the same 800 number, 1-800-669-9594, and learn how to become a volunteer examiner yourself. Well, what do you say we look at some overall, I got to remember this, before we go into some of those Q&As that may give your brain a little twist. In every one of our extra classes, I ask our class members to come up with some great ways to remember some of the correct answers, and I've got some good ones here. For instance, the frequency privileges of amateur extra class For the 80, 75, and 40 meter bands, one student says simply remember that the beginning frequency of the answer must end in 0 and the bandwidth must be exactly 25 kilohertz. This will solve the questions on all 3 bands. And for the 20 meter band, the correct answer is the only split frequency, that is frequency, which has a bandwidth of exactly 25 kilohertz for each of the 2 segments. And for the 15 meter band, 2 answers have split frequencies in which the bandwidth is exactly 25 kilohertz in both segments. The correct answer is the one with the lowest frequency in the second segment. Okay? And remember the time constants for discharge of a capacitor. One of my students says each of these can be solved based on the knowledge that a capacitor discharges to 36.8 of its initial value during one time constant. The first problems have identical time constants of 0.02 seconds. After one time constant, the voltage has dropped on the capacitor to 7.36 volts. That's 20 volts times 0.368. One time constant equals 0.02 seconds. After 2 time constants, voltage has dropped to 2.7 volts, calculated 7.36 volts times 0.368. 2 time constants equals 2 times 0.02 or 0.04 seconds. Progressively, one arrives at answers of 0.02, 04, 06, 08, 0.1 seconds. Now, don't worry too much about rectangular coordinates. One student writes, rectangular coordinates had me brain busted. But then I figured out that rectangular coordinates consist of 2 numbers. The first reflects resistance, and the second reflects reactance. Further, the reactance, the second number, must be preceded by a plus J or a minus J, which indicates whether the circuit is inductive, I positive, that's plus J, or capacitive, negative, which would be a minus J. So they say that for solving rectangular coordinates with series circuits, first determine whether the circuit is inductive or capacitive. This tells us whether the answer should be plus J if inductor is in series, or minus J if it's a capacitor in the circuit. This tells us what sign should precede the second number in the answer. Then the first number, resistance, should be equal to the value of the resistance given in the question. Now, one of our math students, who is also a math teacher, says, problems asking for impedance of a network where the answer must be in polar coordinates, that is, the first number will be the hypotenuse or impedance, and the second number represents the phase angle. Again, if the circuit is inductive, the phase angle will always be I positive. And if it is capacitive, the phase angle will be capacitive negative. Please note that the absence of the minus sign following the slant bar means that the phase angle is positive or inductive. Now, our math instructor says it helps in working polar coordinates to place their value given on a right triangle for a visual picture of the right triangle trigonometry that we're working with. The math instructor says place the reactance on the vertical line, the resistance on the baseline, and visualize the hypotenuse or impedance on the slanted line. And he points out that there are only 3 rules required to work the multiple series circuits which call for polar coordinates. And here are the rules, and this is going to make it much easier. Number 1, if the 2 legs of the triangle, that's the vertical reactance line and the baseline, which is resistance, if the 2 legs of the triangle are equal in value, the phase angle will always be 45 degrees. All right? Number 2, the 3, 4, rule says that, the 3-4-5 rule says that in a right triangle, if either leg has a value of 3 and the other leg has a value of 4, then the hypotenuse or impedance line has a value of 5. That means that if one leg, vertical or the base, has a value of 30 and the other leg has a value of 40, then the hypotenuse or impedance must be 50. If you go up the scale, 300, 400, it'll be 500. 300, 400 will be 500. The third and final rule that our math instructor says is the fact that reactance inductors and reactance capacitors are 180 degrees out of phase and tend to cancel each other. So net out the values given for these components to get the net reactance. And if the value of these components net to 0, if they cancel, then the phase angle will also be 0. All right, thanks to our Midwest math instructor for that helpful series of tips. Now, working the 7 polar coordinate problems involving circuits which are in series. Again, first place the reactance on the vertical line, 100 ohms, and the resistance on the baseline, 100 ohms. We know that by Rule 1, the two legs have equal value, and this gives us a 45-degree phase angle. We also know that the reactance is inductive, and this gives us a I positive phase angle. Look for a positive 45-degree phase angle with the only answer with a non-negative sign in front of the degrees. Wow, that's a great way for solving that. A young lady from Florida who helps teach high school math says, it's not necessary to memorize the schematic symbols for the 2 MOSFET, dual gate MOSFET, and junction field effect transistor. Notice that one must only learn 3 schematics for these 6 components, as the schematic is the same for each component, with the only difference between the N channel and the P channel for each, and that is the direction of the arrow. Another student in the South Sea says that you must be prepared to recognize schematic symbols and descriptions of 5 different digital logic circuits. And they give you this little refresher. The AND produces a logic 1 output if all inputs are logic 1. The NAND, produces a logic 0 output if all inputs are logic 1. The OR produces logic 1 at the output if any inputs are logic 1. The NOR produces logic 0 output if any or all logics are logic 1 on the input, and the NOT produces a logic 0 at the output if input is logic 1 and vice versa. And she also says that when the circuit name begins with an N, it produces logic 0. Otherwise, they produce logic 1. She also points out, notice also that when the circuit name begins with N, the schematic symbol has a small circle at the point of output. Well, that's pretty good. Now, in connection with the above, another student says digital logic circuits also have polarity. And several problems involve the state or level of logic circuits based upon their polarity. All such problems can be solved by developing a table to represent the state of logic circuits based on whether their polarity is positive or negative, as follows. And they suggest learn the positive and reverse it for negative. All right, if the polarity is positive, it'll be a logic 1 that is called a high state. If the polarity is positive and a logic 0, that'll be low. Now, if it's negative polarity, the 1 is low and the negative is high. Here's a letter from a student up in Alaska that says, I've got it figured out on the bandwidth problems. There are many problems presented which deal with calculations of bandwidths. The formula for computing bandwidth in hertz for all problems is the same except for those dealing with CW signals. Now, for those digital bandwidths where they give you a baud rate, it's baud rate plus, paren, 1.2 times the frequency shift. And she indicates these are straightforward, and only in a few cases where the answers are given in kilohertz do the hertz have to be converted as per the conversion. To convert from hertz to kilohertz, move the decimal point 3 places to the left. Now, to calculate the bandwidth of CW emission, the formula is 0.8, not 1.2, but 0.8 times word per minute times 5. Notice that the bandwidth for both 5 WPM calculations are the same, but we don't have that question anymore on the test. But you do have the 13 word per minute bandwidth calculation. Now, problems given on the computation of beam widths of an antenna that produce symmetrical patterns. The formula for those computations, as one student in the Midwest indicates, involves dividing a fixed calculated value of 203 by the square root of 10 raised to a power represented by the antenna gain and dB divided by 10. The answer obtained are straightforward and no conversions are required. However, it's good to have a calculator available. And again, yes, on your examination, calculators are okay. They also point out that since none of the correct numbers is repeated in other problems, the bandwidth of symmetrical pattern antennas can be obtained by simple recall, and that's actually, he should say beam width, simple recall of the following magnitude numbers: 6, 20, 36, and 51. Anytime one of these numbers appear in a multiple choice answer, it is the correct number. 6, 20, 36, and 51. There you go. Now, 8 problems, says another students in Boston, are given which ask for the reactance of transmission lines of differing wavelength when the line is open or shorted at the far end. The following table, which I'll read to you, will permit recall to answer all of these questions. And simply learn 1/8 wave and 1/4 wave and simply reverse your answer for 3/8 or a half. 1/8 wave, if it's shorted, it's inductive. 1/8 wave, if it's open, it is capacitive. Quarter wave, shorted is high, that's the reactance, and quarter wave, open, is low. Half wave, shorted is low, open is high. Another one of our amateur radio operators writes, with regards to transmitter frequency variance, notice that the frequency is in million of hertz, megahertz, and the time-based accuracy is in parts per million. So based on the frequency given, like 146.5 or 432.1, you have the answer for all the questions asking for plus or minus 1 part per million. Then for plus or minus 0.1 part per million, simply move the decimal place 1 place to the left. So the decimal point is moved 1 place, there we go, to the left. And for plus or minus 10 parts per million, move the decimal point 1 place to the right. And the answer is always in hertz. Another candidate says that they had a problem with the magnitude of impedance of series and parallel RLC circuits at resonance, but the characteristics of current flow in a series or parallel RLC circuit at resonance can be calculated with some of the difficulty overcome by remembering that in regard to the magnitude of impedance of these circuits, it is approximately equal to circuit resistance in both series and parallel, and current flow is at maximum in both of them. All right, that's a good one. Another student writes that there'll be test questions with resonant frequency with values given for L and for C. And he points out all problems can be worked by the application of one single formula. The resonant frequency in megahertz can be arrived at for each of these by dividing 1,000 by 6.28 times the square root of L times C. And since the correct answers are always given in megahertz, no conversion is necessary. My friend Jerry in Southern California writes that there's some computations of the half-power bandwidth of parallel resonant circuits. He says this is easy. All problems can be solved by application of one simple formula. Divide the resonant frequency, which is given in megahertz, by the Q of the circuit. And since all answers will be given in megahertz, to convert them to kilohertz, simply move the decimal 3 places to the right, megahertz to kilohertz. To go from kilohertz to megahertz, KLM, move it 3 places to the left. And problems dealing with calculations of the Q of a circuit, this is accomplished in 2 steps. First, compute the inductive reactance in ohms by multiplying 6.28 times the frequency in hertz, and then multiplying the result times the inductance in henries. Now, since each of the problems state both frequency and inductance in millions, mega and milli, it is not necessary to convert hertz and henries respectively. He says one can simply multiply 6.28 times the frequency, given in megahertz, and then multiply the result times the inductance, given in microhenries, then divide the net result obtained into the resistance, given in ohms. Oh, another great hint. From a young lady out of South Carolina, she says, rather than go through the detailed computations required to solve these 10 problems using trig tables, meaning those tangent problems, calculate the tangent of x degrees. The candidate may wish to solve the problem by following 2 simple steps. Yeah, that's for me. First, look at the information given in each problem and determine whether x sub c is less than x sub L or greater than x sub L. If x sub c is less than x sub L, then the voltage is always leading the current, E line. If x sub c is greater than x sub L, then voltage is always lagging the current, and that is ice. Once this is known, there are only 2 solutions in which the voltage leads or lags, and the correct answer is always the one with the smallest degrees. All right, thanks for that letter. Another student writes in that simple to solve for the power factor in an RL circuit with 3 different degree phase angles, 60, 45, and 30. If you have a calculator which gives cosines, the problem can be solved by simply obtaining the cosine for the degree phase angle. But if your kids kept the calculator and won't give it to you, you may wish to remember the power factor appropriate for each phase angle. 60 degrees is 0.5, 45 degrees is 0.7, and 30 degrees is 0.8. Here's a teenager that writes in that they've got a great way for just, without having to write down anything, calculating the effective radiated power. Remember those problems? If the dB net gain is 3, the power output would double. Okay? If the dB loss is 3, the power output would be cut in half. If there is no net gain or loss in dB, the power output would remain the same. Then, if there is a 1 dB gain or 1 dB loss, the increase or decrease in power would be about 1/3 of that for the 3 dB effect. All right? If the dB gain or loss is 2, the power output increase or decrease would be about 2/3 of that for the 3 dB effect. Thank you, young man, for that one. Another math instructor out of the Southwest writes that some folks have trouble with the terms alpha and beta, particularly when dealing with alpha and beta cutoff frequency. He points out that a good memory jog is to remember that the term alpha has to do with emitter current and the term beta has to do with base current. Conversely, when you are questioned about the alpha cutoff frequency and the beta cutoff frequency, the association reverses. That is, alpha cutoff frequency has to do with base configuration, and beta cutoff frequency deals with emitter current. Okay. Another student says, I've got it. Those questions regarding the character of each class of amplifier. Class A, output throughout the entire signal cycle. Input never goes beyond cutoff. Class B, essentially in 180-degree pulses. AB, more than 180 degrees but less than 360. And Class C output less than 180 degrees. All right. Class A, he points out, has the highest linearity and least distortion, while Class C amplifier has the highest efficiency and is distinguished by the bias set beyond cutoff. Now we have someone else who's identified components: L network, one inductor and one capacitor. Pi network, one inductor and two capacitors, or two capacitors, one inductor, or two inductors and one capacitor. Pi L network, two inductors and two capacitors, has the greatest suppression of harmonics. L network matches a small impedance range. Pi network offers greater transformation ratio, and Pi L network offers greater harmonic suppression. Oh, here's an interesting one dealing with the calculation of plate current and amperes. Problems that divide the plate voltage by the plate current in amperage. The plate current has to be converted to amps in accordance with the class of amplifier. The current must be multiplied by 2 for Class C, 1.57 for Class B, and 1.3 for Class A. The fourth problem involves transistor amplifiers solved by dividing the collector voltage, which must be squared by 2 times the power output. And then he says, for those with a good memory, the correct answer to these questions is not repeated in any of the other questions. This means that anyone who can remember the magnitude of 14, 1500, 6700, and 7600 has the correct answer anytime such numbers appear. Okay on that one. A young housewife writes that, remember, deviation ratio is maximum deviation from the carrier frequency divided by the maximum audio modulating frequency. She writes small number always into the large number. Modulation index, frequency or carrier deviation divided by the modulating frequency, small number into the big number. Now remember the electric and magnetic fields of a radio wave. Remember that an electromagnetic wave is made up of 2 fields, electric and magnetic. Further, these 2 fields are always out of phase by 90 degrees. As a result, when the electric field is parallel to the Earth, the magnetic field is vertical and vice versa. Also, the fact that the electric field is always in phase with the polarization of the antenna means that if they give you the electric wave, that is the polarization of the wave. Notice the ease of solution with we know that polarized horizontally or parallel, we know that the electric field is horizontal or parallel, and the magnetic field is vertical or perpendicular. If the wave is polarized vertical or perpendicular, we know that the electric field is vertical, and the magnetic field is horizontal or parallel. If the electric field is horizontal or parallel, we know that the wave is polarized horizontally or parallel, and the magnetic field is perpendicular. Here's another memory jog from another student. Effective voltage times 1.414 will result in peak voltage. Peak to peak voltage equals peak voltage times 2. RMS, or average voltage, or heating voltage, equals peak voltage times 0.707. So peak to RMS, multiply peak by 0.707. Again, remember those amplifiers, class B, AB, and C. Remember that the 0.6 is for class B, 0.5 for class AB, and 0.8 for class C. Oh, and the physical length of antenna feed lines, another student writes, all answers are given in meters. However, the length in feet can be calculated by dividing the frequency in megahertz into the product of 984 times wavelength of the transmission line. Quarter wave, 0.25. Half wave is 0.5 times the velocity factor. And the velocity factor of most coax is going to be 0.66. Now, as we get ready to take the test, there's some additional things that you can do to ensure you're going to do just fine on the upcoming extra class exam. One is to work my book by taking a highlighter and highlighting the correct answer. Then, after you've gone all the way through the book highlighting the correct answer, go backwards and review only the correct answer and look at the correct answer and see if you can figure out what the question is. Don't be real concerned on the frequency questions, because the American Radio Relay League is going to be asking the Federal Communications Commission to refarm the novice subbands, so 80 meters, 40 meters, and 15 meters may be no longer test questions. And don't worry about it if they do change the frequency allocations for extra class. We get more voice frequencies, and you'll find that they will omit those test questions on the exam. But how are you in knowing the correct question if we give you the answer? Let's go ahead and try something. Primary service and secondary service. That is, each ITU region, the bands are allocated internationally. How about the answer, you must evaluate the height of your antenna based on FCC Part 17. Well, that is if you live within 5 miles of the airport. How about the answer, never? U.S. citizens are not eligible for alien reciprocal operation. That goes along with the question, when may a U.S. citizen holding a foreign amateur service license be authorized for alien reciprocal operation in the USA? The answer is never. IARP agreement. Remember that one? That is the multilateral and bilateral operating agreements that allows FCC licensed U.S. citizens to operate in many Central and South American countries. How about all frequencies authorized to the amateur service? Well, that'll be you with an extra class. Also, what frequencies are normally available for RACES operation? How about an amateur station located more than 50 kilometers above the Earth? That is a space station. How about an amateur extra VE or qualified supplier who selects questions from the appropriate VEC question pool? That would be the question, who may prepare an Element 4 ham radio exam? Remember, on the satellites, mode H, 21 to 30. That is where the satellite is receiving. Mode V, VHF, 144 to 148. Mode U, ultra-high frequency, 435 to 438. And Mode L, 1.26 to 1.27 gigahertz, where the satellite is receiving. 240 lines per minute. Remember that question? All about fax images transmitted over ham radio. Signals not using the spread spectrum algorithm are suppressed in the receiver. That's why our received spread spectrum signals so resistant to, that's right, interference. What does the TNC show when it's in the command mode? It shows CMD, ready to receive instructions from the keyboard. The answer, PSK 31. That is, which of these digital communication modes has the narrowest bandwidth? The answer, frequency. Figure that one out. Frequency. What parameter does the horizontal axis of a spectrum analyzer display? How about the vertical? That's amplitude. All right. The answer is 146.52 hertz. Well, that would be the frequency counter with an accuracy of plus or minus 1 part per million, operating at 146.52 megahertz, will have a potential error of 146.52 hertz. If it is 0.1 part per million, it's going to be much tighter, only 14.652. If it's 10 parts per million, it could be off as much as 1,465.20. All right, let's give you another one. How about an answer of 119 dB? Figure that one out yet? 119, that's the blocking dynamic range for a typical HF receiver. Nonlinear circuits or devices. What causes intermodulation? Thunderstorms. What causes atmospheric static? Studying too hard for the exam. What causes a headache? Resonance. What can cause the voltage across reactances in series to be larger than the voltage applied to them? All right, let's try some questions and some short answers. A graph that can be used to calculate impedances along a transmission line, that's right, a Smith chart. And the two families of circles that make up the Smith chart are resistance and reactance. Oh, you're doing really well on all of this. How about when using rectangular coordinates to graph the impedance of a circuit, what does the horizontal axis represent? Well, the horizontal is the voltage or current associated with the resistive component. And how about as the frequency increases, RF current flows in a thinner layer of the conductor. Whose effect? That's right, that is called skin effect. Potential energy, that's the term for energy that is stored in an electromagnetic or electrostatic field. Reactive power, what's the term for out-of-phase, non-productive power associated with inductors and capacitors? That is reactive power. A microwave frequency, frequencies. My goodness, what is at microwave frequencies? That is gallium arsenide used as a semiconductor material, and it's preferred over germanium or silicon at microwave frequencies. What type of semiconductor material contains more free electrons in pure germanium and silicon? That is N-type. And remember, the majority of the charge carriers in P-type semiconductor materials, that's the holes. All right, you're doing really well. Silicon and germanium, two elements widely used in semiconductors, exhibit both metallic and non-metallic characteristics. Know what a light-emitting diode looks like? And know that by varying electromagnetic fields, this is how the electron beam deflection takes place in a Vidicon. And the length of time the image remains on the screen of that old-fashioned radar scope, that is called CRT. That's right, persistence. What material property determines the inductance of a toroidal inductor with, let's say, a 10-turn winding? Core permeability. What's not true about a CCD device? Well, a CCD device cannot be used. That is, it cannot be used as an analog to digital converter. So the answer, which is not true, the answer is a true one. It can be used as an analog to digital converter, but they're saying what is not true, that is the correct answer. And if you think that sounds confusing, I asked the question pool committee not to put in those double negative, what is not true. Okay. Remember, the CCD, it can be used to change analog to digital. The answer is no. That is something not true about it. The principal advantage of a liquid crystal display, it consumes low power. A good SSB filter, 2.1 kilohertz at minus 6 dB. Double sideband 6 kilohertz. FM as much as 15 kilohertz. Integrated circuits, monolithic integrated circuits for microwave. They work at how many volts? 12 volts. TTL operates at what voltage? Around 5 volts. Positive logic circuit. What level is used to represent logic 1? That is high level. In a negative logic circuit, what circuit is used to represent a logic 1? Just the opposite, a low level. Know those little schematic diagrams to know all the different capacitors and resistors and what they do. What type of filter are you going to put up at your 2-meter repeater duplexer? That's called a cavity filter. A Zener diode, what does that do? That is a stable voltage reference in a linear voltage regulator. And a series regulator is used in applications requiring great efficiency. The shunt regulator is where the constant load, and it needs one, on an unregulated voltage source. And the Zener diode voltage will result in the best temperature stability, 5.6 volts. How is the F3E FM phone emission produced? With a reactance modulator. Remember that? Reactance modulator. We use a balanced modulator followed by a filter to generate, that's right, single sideband. Detection, the recovery of intelligence from a modulated RF signal. The answer is 2 times. That is, starting at a positive peak, how many times does a sine wave cross the 0 axis in one complete cycle? So you see, having someone read you the correct answer that you've now highlighted in my book is a great way to recall what the question is. The answer is 3. Well, modulation index equals peak deviation, which is, in this case, 3,000 hertz. Modulation frequency, 1,000 hertz. 1,000 divided into peak deviation of 3,000 hertz, or I should say, more mathematically, Alan would tell me, mathematically it's 3,000 divided by 1,000. And that comes out the answer 3. And the 3 is also the same answer for 6 kilohertz modulated with a 2 kc modulating frequency. Pulse duration in a pulse width modulation system. Pulse position, the time at which each pulse occurs. The receiving station automatically requests repeats when needed. That is Amtor mode A. But if the transmitter is sending everything twice, the Amtor mode is Amtor mode B. Well, congratulations. You made it all the way through this audio course. This is Gordon West, WB6NOA, and we wish you the best of success on your upcoming extra class 50 question test. Play this audio course over and over again, read over my book, and you will be all set to max. Get an A on your upcoming extra class VE administered examination for the top license, the amateur radio extra class ticket. Now, when you pass the test, be sure and follow the instructions in the back of my book for writing me for that free certificate that I'll sign personally that says you graduated with extra class. You'll enjoy hanging that on your wall. Stay in touch with me at WB6NOA at ARRL.net, and I look forward to working you on the extra class bands soon.